Hello and welcome to R&D Mathematics. Today we are going to talk about one-to-one functions. If you can remember, when we started talking about functions, we drew three diagrams. Let me draw them again. So domain and range, domain and range, and domain and range. And I told you all of these are relations. First one-to-one relation. And yes, that's the function. Second one-to-many relation. So it's not a function. Not a function. And third one, many to one, and yes, it's a function. Now the first one is known as one-to-one function. So that's the basic idea. Now this is the exact definition. For a given function, if no two x values map to the same y value, that means we are actually avoiding that third case, then the function is one-to-one. Now if you think about graphing, like if you think about a linear graph, a line, simple word, a line. See, if I choose some x value with the corresponding y value, this y value, there is exactly one y value, right? So all linear functions are one-to-one. And linear functions are not the only things that's one-to-one. For example, something like this is also one-to-one. But what I want to say, for example, like quadratic functions, things like this. See, if I choose, let's say this x squared, if I choose 3, so f of x is x squared. Look at this, f of 3 is 9, right? And how about f of negative 3? That's also 9. So f of negative 3, that's also 9. So we have two different numbers going to same one. So this is not one-to-one. See, it looks like this. It's a function, but it's not a one-to-one function. I think now you clearly understand what one-to-one functions are. Now with this kind of drawing, actually we have a nice test. Horizontal line test. Now this is completely different from vertical line test. Vertical line test is actually to check whether it's a function or not. This horizontal line test is to check one-to-oneness. One-to-oneness. Now let's see what the test is. If every horizontal line, every, that's important. Every horizontal line, so infinitely many lines, intersects the graph of a given function in at most one point, so not more than one point. then the function is one-to-one. Function is one-to-one. Now at most, that means not more than. So let's see some examples, then you'll understand this. Now, how about this, this. First of all, let's start with the second one. Second one, any horizontal line. Well, one is enough because, see, one line, this line, and all the lines, they violate the definition. So there are lines that intersect the graph more than one point. So this is not one-to-one. And for this guy, it looks like x cubed graph. It's one-to-one, right? No matter how many lines you draw, it's only crossing one. So this is one-to-one. And both of these two guys are functions actually, because they satisfy the vertical line test. Vertical line test, let me remind you, if you draw any vertical line, it's only hitting your graph once. This guy is not even a function, so not a function, it fails the vertical line. But here in today's video, we are talking about horizontal line test. So remember, horizontal line test we used to check whether it's a function. We already know, sorry, we used to check whether that's a one-to-one function. We already know that's a function. I just drew this one in order to remind you the vertical line test. Now, moving onwards. Checking algebraically whether a function is one-to-one or not. Now, if you see a quadratic term, it's not going to be one-to-one, but it's not just a case quadratic. So for example, let's say f of x equal 2x plus 5. This is going to be one-to-one. Why? You know it's a linear function, but there's a nice way. So, let me write down the test over here. I forgot to write down. So this is the test. If fa equals fb, so a and b some two numbers, then we must have a equals b. Now, what does this mean? So this is an abstract way of telling that last figure is not the case. Not the case. So what does read carefully. If fa equals fb, see, if fa equals fb, then those a and b should not be two different values, but rather they must be the same. That's what it says. Then it's one-to-one. So that's the algebraic way. This is a little bit abstract way. So what you need to do actually, set f of a, so that's 2a plus b, and set f of b, that's 2a plus 5 and 2b plus 5. Now so you make them equal, assuming, so you assume, so if they are equal. So if they are equal, then you check by simplifying it what's going to happen to a and b. 5's will cancel, then 2a equals to b, 2's will cancel, see, a equals b. So yes, this is one-to-one. Now let's take an example and see where something is not one-to-one. So how about this fx equal absolute value function plus 1. Actually, if you draw the graph of that, absolute value graph looks like this, so plus 1, it looks like this. Now set fa, a plus 1, set fb, b plus 1. Now if these two guys are equal, then you are getting 1 will cancel, absolute value of a equal absolute value of b. Now when you simplify, a is going to be plus or minus b, so that is not 1 to 1. Now this is an abstract way of talking about this horizontal line set test. See guys, see, let's say this value is a, and there is another value b that will take you to the same y height, right? Two different values going to same y height. In other words, if you draw it in the domain range diagram, there are two different values goes to same y height, right here, this height, that value. So this is not 1 to 1. Okay guys, I hope that's I hope you understood well what one-to-oneness is. In our next video, we will talk about inverse function, and we need this one-to-oneness in order to talk about inverse function. That's why we did it just before inverse functions. Thank you.